All right, thanks everybody for joining today after the summer break that we had. We're going to have two weeks in a row of perfSONAR talks, and with a similar set of presenters. We have several students and staff here from the University of Michigan today, and I'm going to turn it over to Mark Feit to give everybody's introduction and to introduce a little bit about the topic. So I'll turn it over to you, Mark.
Thanks, Jason. Hi, everybody. My name is Mark Feit. I actually work for Internet2, not the University of Michigan, just to make that crystal clear. But I am a member of the perfSONAR development team, and I have been mentoring just about everyone from Michigan that you see listed here this summer. They're part of the intern program, and they're going to talk to you today about their use of the plugin development kit, which is something that was also developed at Michigan for writing new plugins for pScheduler, which of course is part of perfSONAR. So on that note, I will turn it over to Frank, who is first in line. Frank, take it away.
Hello, everyone. Thanks again for coming. Again, my name is Frank Wang. I'm here with Ali, Alyssa, Samuel, Maxwell, Yihua, Daniel, and Jing. We're all currently interns at the University of Michigan, and today we'll be talking about perfSONAR, but more specifically, the plugin development kit. And just so if you have any questions during the chat, during the talk, feel free to leave them in the chat. So before I get started, I'd like to explain a little bit about what perfSONAR is for those of you who might not be familiar with it. So perfSONAR is an open source network benchmarking toolkit, which relies on other open source tools as plugins to gather performance metrics. There are thousands of perfSONAR instances deployed worldwide to aid with testing and monitoring network health and performance. So the University of Michigan became a development partner with perfSONAR in 2016. And since then, they've been pretty involved with perfSONAR, most notably through the internship program. So every year, the University of Michigan Information and Technology Services will have some interns form a cohort group that will help write plugins for perfSONAR. And as Mark mentioned, some of the interns a few years ago also created the plugin development kit, which really helps focus the development of plugins on making measurements rather than trying to integrate it into perfSONAR itself. So this presentation will be talking about perfSONAR's architecture, as well as some of the tests and tools and the existing plugins. But the bulk of this presentation will really be focused on how to develop your own plugins if you're interested in getting involved in this open source project. So here I'll briefly go over the architecture of perfSONAR. The main thing in perfSONAR is this thing in the middle called pScheduler, and this is what interacts with all the other parts of perfSONAR to perform measurements and send measurements and everything else. So this talk will mostly be focused on this bottom section here that are labeled tests and tools. These are what actually perform the network measurements. You can see that the tests are called things that you might expect from a network measurement system, such as throughput or round trip time. And the tools will be the things that you use to get them. So it's really important for anyone who develops plugins to know the difference between tests and tools. So I'd like to explain a little bit more about the difference between the two. As I mentioned, tests are the measurement itself. It's more of an abstract definition. It just says, this is the measurement I'm going to get. These are the arguments I can take, and this is what my result will look like. However, the tests themselves don't actually run the measurements and get the numbers. What pScheduler will do is it'll tell the test that it wants to get a measurement, and then the test will generate a specification file and send it to the tool. And the tool is what actually performs the measurements. So it'll take the input from the test and then run the measurement and then produce an output that matches the test's defined result. And also, it's important to note that every tool that is in perfSONAR might also be run with several tests, and every test might also be run with several tools. There are also archivers in perfSONAR. We won't be mentioning them that much during this talk, but their role is to send measurement results to other systems.
Thanks, Frank. So as you can see, here's a list of all the current pScheduler tests. As Frank said, these all abstractly define their own measurement as well as the result. The ones highlighted in yellow were developed at the University of Michigan, mostly through the intern program. Listed here are all the current pScheduler tools. More tools can be written in the future to generate new measurements or also generate similar measurements, but in a different process to be used with prior tests. Again, all the tools highlighted in yellow were developed at the University of Michigan. Last but not least, you have archivers. As you can see here, there are a lot less archivers than there are testing tools, but that doesn't mean that they're not important. If you need to send your data to another platform or somewhere else to analyze it, you might want to create an archiver. So this summer, our intern group has been working really hard to bring new tests and tools to perfSONAR. While in this presentation, we'll not be going through these plugins, but more so our process to create these. Next Friday, we'll be back to talk about them. So we're going to move on and talk about the processes required to create these new plugins. The first thing that's needed to develop plugins is a development environment. To create this, we started off with a fresh CentOS 7 installation. From there, normally you'd have to create users, manage SSH keys, IP restrict, or install other software dependencies that are necessary. Unfortunately, this can take a really long time and can prove really detrimental if you wish to bring up multiple development environments in a short period of time. To speed this process up, as well as automate it, we have decided to move it on over to Ansible. To the right, you can see our Ansible playbook running against just a single host to set it all up. If you wish to see the exact commands that we are running and the output of them, you can set the video to quarter speed and it'll become a lot more legible, as well as you'll be able to read the output. Within our Ansible playbook, there are 4 roles. The bootstrap del role takes care of setting up users, generating SSH keys, while the other 3 roles install the respective software dependencies. These 3 software dependencies are necessary to bring up the virtual environment to develop plugins, which we'll be going over next. I'm going to hand off to Daniel, and he's going to talk about the PDK and bring up the virtual machines.
So once your development environment is ready, you're now ready to set up or bootstrap the plugin development kit, or the PDK, which is what we actually use to develop the plugins. And to begin, we first have to use Vagrant environment to build and access our virtual environment. And to do this, you should first edit the Vagrant file and specify development box and username. As you see in the video to the right, this is what all these commands should look like in the terminal. And as Maxwell stated earlier, if you want to see this video and really see the output and what the actual commands are, a link to the presentation will be provided, and you can slow down the video to a quarter speed. So after editing the Vagrant file with the development box and username, you should then run the command Vagrant up. And what this command does will automate the building of your virtual environment with the operating system that you select. After doing this, you can then Vagrant SSH into your Vagrant account and access the virtual environment that you just created. Once your virtual environment is made and you're inside that virtual environment, you should then go on to building pScheduler, which is where PDK will be located. To do this, you should fork the GitHub directory of the pScheduler and then clone your fork directory. And then after that, inside your fork directory, you should run the command sudo make to actually build the pScheduler directory. Before doing anything else, you should make sure pScheduler is working and troubleshoot any problems that you have. And if everything is working smoothly, you should now be able to access the plugin development kit, or PDK. So in terms of using the PDK, as I stated earlier, PDK is located within pScheduler. So once you have pScheduler ready and it's built properly, you can then navigate to the PDK by going into the scripts directory and then the PDK directory. Once you're within the PDK directory, you can then use a template to create tests, tools, and archivers. To create a test, you run the command /plugin dev, select test or archiver. In our case, we only did tests, but archivers can also be useful. So for us, we specify test, and then we state the name of our test. As you can see in the image to the right, this is what that should look like. On the top command is what it should look like, and a directory is made for that test. Similarly, if you want to do tool, you do the command /plugin dev. You specify that this will be a tool. You then give the name of the test associated with this tool and the name of the tool. And again, on the image to the right, it's a very similar process. The tool plugin is made and a directory for that tool is created. Before doing anything else, you should do the initial build and run the sleep program for the test and tool respectively. And to do this, you can go into the test directory and run the command sudo make cvic and do that same thing for the tool directory as well. Once your test and tool are working properly, you can then run them in tandem to do the actual plugin by running the command below. We will now move into test development, and plugin development in general, and we'll be using the MTU plugin as an example for how test development and tool development should work. And first, we'll be focusing on test development with the MTU plugin. Before doing anything else, you should first go to the test directory and run the command cd pschedule. Go to the test directory and run the command grep-order star. And what this does, it will state the order that each of these files should be ran and all the files that will be needed during test development. As you can see in the image to the right, we were inside the MTU directory, and it lists all the files that need to be made and the development order in which they should be developed and ran.
So when you first start developing your test, the first file you'll look at is this pscheduler-test- whatever you named your test.spec file. The code in here is what will build your test into pScheduler. For the most part, this file will work as generated by pScheduler. The only thing that you might need to change in here is where you can see it says include all required libraries here. If you'll need to use any specific libraries, you can add them there so that they're built into your test. pScheduler already includes a lot of basic Python libraries, so you won't have to worry about those, just anything very specific to your test. In our MTU example, you can see that we didn't have to add any libraries here, and the default libraries were sufficient. The next file you'll need to edit is called enumerate. And this file provides information that describes your test to pScheduler. Again, most of the pre-generated code here is sufficient for a new plugin. You'll just need to edit where it says description. On a blank enumerate file, this will say edit me, and you can just replace that with a brief description of the function of your test. And you can see on the screen how we described the MTU plugin. The next file is validate.py. This file just describes what valid input and output looks like for your test. With everything that you add to validate.py, you have two options for the data type. You can either define your own custom data types, and you can see in the screenshot where you would add those. It says here with the local key. These are good if you need really specific types of information passed to your plugin. But if you don't need that, you can also use pScheduler's predefined data types. In validate.py, there's a link to a file that'll list out all of the data types that are already available to you in pScheduler. So you can look there and see if any of those suit your needs. In terms of edits in this file, you'll start with spec-is-valid, and you need to add any and all command line options that your test is going to use. And you can see for MTU, the first three options here were pre-generated, but we needed to add destination and port. Both of these can be used to generate the MTU, but only destination is really necessary to make the measurement. So dest is the only option listed under required. Make sure that you're only putting options in required if they are absolutely necessary to run your plugin. If you could use a default value or take the measurement without it, you don't need to include it there. And then after you're done editing spec-is-valid, you can edit result-is-valid in a very similar way, just instead of adding the input, you're adding the output. So any and all fields that you want your test to output, you'll put them there alongside their types.
The cli-to-spec is to convert command line options into a test specification of JSON format. Firstly, it will extract the arguments from the input command line, and if it is not none, it will add these arguments to the options of parser. Here's an example of one of the arguments source. And in the example below, the source argument has been input in the command line, and the output will be the source information in JSON format. And as you can see, if there's no host node option, it will raise the error message, no such option. Yeah, and the spec-to-cli is to convert JSON file to command line. Firstly, it will decide whether the JSON is valid. If it is not, it will raise an error message. And if it is valid, the command line will be built and arguments are added as tuples. For example, there's a JSON file called example spec.json. When we input it into spec-to-cli, it will build the command line accordingly. And the next file is spec-is-valid. This file carries out the validation function you defined in validate.py, runs spec-is-valid on a test spec, and decides whether to proceed or throw an error. In most cases, this file works as generated by the PDK, so you don't need to edit.
In test participants, the spec is validated, and if it's not, it would fail. The host names and IPs are taken out of the spec and outputted out as participants. And if the host does not exist, a corresponding message will be given. Here in MTU specifically, source and source nodes are used instead of host as a slide modification. So the participants come from the source and source nodes that exist from the spec. For spec format, the spec is first validated with spec-is-valid and failed if it's not. Then be converted to either one of the two supported formats, HTML or text. Here for the MTU plugin, the MTU spec is outputted in the two formats. And then in test result format, the test result is validated with result is valid and failed if it's not valid. Then it will be converted to one of the same two formats mentioned earlier, text or HTML. And here you can see that the results are specific to MTU results.
So before we were developing the MTU test, now we'll be walking through the development of the MTU tool that goes with the MTU test. So for developing the tool part of the plugin, it's similar to test development. You put this grep-r order command that's on the slide in the tool directory, and then you're given the order in which you'll view and tweak the tool's files. So we'll look into these files in more detail in this order. So this .spec file builds the tool into pScheduler, and if there's any additional requirements or packages that will be needed for the tool, they would be included in this file. Other than that, not a lot will need to be changed since it gives information about the tool, which is filled in automatically, as you can see on the side, like the name of the tool, which is MTU, the version of perfSONAR it uses, its license, etc. We would change the summary in here for more information about the tool if we want to be more descriptive. And so enumerate is the first file you're most likely to edit, since the JSON data in here describes the tool and, more importantly, what test it uses. In this specific case on the right, the MTU tool obviously points to the MTU test, so that would be something we put into the enumerate file. We would also make sure the description is how we like it, and if not, we could change it. For the can run, like the name implies, it checks to see if a tool can run based on a test spec. In here is where you would make sure that the tool knows what it's capable of. So since the MTU test only has one tool, which is MTU, it isn't really a great example of why this file can be important. So I'll use another test as an example, like throughput, that has multiple tools. So when throughput looks for a tool to use, like iperf3, iperf2, new TCP, or speed test, each of those tools would look at what they would have to measure for the test. And if they can't support the test spec parameters or the measurements that's desired, the tool would mark can run as false and tell pScheduler that it can't run the test. You would edit this file to input the name of the test the tool is compatible with, as well as to check which parameters will work or not work with the tool. And so exactly like this file is named, it simply determines the duration that a tool will run for when running a test. And this can be changed since the person developing the plugin would have a sense of when a tool has been running for too long and it seems like it isn't working. In the case where it goes over the duration, the tool times out and reports that it took too long. Since MTU is a very quick tool to run, it should need only 5 seconds to run. If it takes longer than that, there's probably something that isn't working right, so we could go ahead and kill the program.
All right, and so the run file is going to be where you actually perform all the commands and the operations that you need to do to get to the results that you made the tool to produce. So the arguments are going to come into it as a JSON object straight from the text, or from the test, sorry. And so we'll know they have already been consistently formatted, and all the values will have been validated for syntax errors. So then we're going to perform the actual work on the test. In the MTU example, it's going to be that find MTU function you can see there, and that's going to be what implements the tool's functionality like further up in the file. But so once you get the results from that, you're going to send that back to the test. But you're also going to send back some other information along with just the raw results, including a succeeded Boolean, which is just going to tell whether or not the tool completed without any errors, and then also an error string and a diag string. And these are just going to give the test some more information about what specifically went wrong and where it went wrong in the event that you had a failure. And these are mostly just to let the test know right away if anything went wrong with the tool before the result format program might start parsing through what could be potentially nonsense output. So these 4 key value pairs are going to be what's packed up into a JSON object and returned right back to the test once the tool is done running. And we leave the result formatting to the test because it makes it a lot easier to ensure consistency in the output when the test can invoke multiple different tools and they all have their own run program. So then once that's done, you should have a working plugin. So during development, you may want to test some aspects of your plugin along the way. One way to do that is to rebuild the whole tester tool that you're working on every time you make a change and then rerun the entire plugin with some test data. And while the cbic or the clean, build, install, and clean again, make file target does a great job of automating the rebuild process, it can kind of be tedious and slow to use this in the stages of development where you still have to constantly make changes and see the effects of them to continue debugging. So this approach usually makes sense towards the end, or if you're trying to test the plugin as a whole. So you can also run some of the individual programs directly from the command line. For example, running that second command on the screen is going to test how your cli-to-spec and your spec-format programs will take the command line arguments you'll be using for your test and then format them into the spec JSON that's given to the validate.py program. Once your spec JSON looks right, you can pass that into validate with a third command up there and change parts of it along the way to make sure your validator catches all the possible syntax errors that may come up in the command line arguments. And once you know all those test programs are working, you can pass the example spec into the run file to test the behavior of your tool. Finally, once you have the results JSON from the run program, you can feed that back into result format with the last command up there, and then work on formatting the text and HTML output. So in the future, hopefully the plugin development kit will be able to be even further improved to make it even easier and more straightforward for individuals to develop plugins to suit their needs. We also hope to be able to automate some more of the process of setting up the development environment so that people can get started on development easily without getting hung up on this first step. And then also making some more documentation and guides for the development process is another thing that could be really helpful for those working on plugin development, especially those who don't have a whole lot of outside help. And that's basically it. We'd just like to say thanks to Mark Feit at Internet2 for his great walkthroughs and his explanation of pScheduler, and then all the technical help and guidance he gave us throughout the development process. And also Eric Boyd here at U of M for stepping in as an additional resource and mentor for us to go to. We'd also like to thank Rob Thomas for sharing his management advice and experience and checking in on us throughout the project, and Katerina Thomas for her feedback and help with putting together today's presentation. And then finally to the ITS internship planning team for all the work they've done to make the program possible, and especially all the logistics that went into this year and last year to make working remotely as productive and comfortable for everyone involved. And so if there are any questions, we'd love to answer them.
All right, well, thank you to all the speakers for giving us that overview. Looks like a lot of work this summer, and hopefully this will lead to a couple of good plugins to integrate into the perfSONAR tools into the future. So if anybody does have any questions, please just type them into the chat and I'll read them off so that somebody can try to answer them. I have a couple that I wanted to start with. What do you think the the most fulfilling part of the work this summer has been, and that's not to anybody in specific, but if anybody wants to just sort of highlight some things that you learned or that you'll be able to use into your future careers once you leave the University of Michigan.
I would say for me, first of all, it's like most fulfilling probably is it's pretty cool that this what we're working on is like something that will be used by like people all across the world, all across the country, which is pretty interesting. It's not just like a U of M specific thing, which was pretty exciting and part of the reason why I think a lot of us joined this project. In terms of like a learning experience, sorry, I would say this type of plugin development was very different from previous coding that I did. Like we separate instead of like one huge program, everything was separated into all these individual files that are ran simultaneously, like not simultaneously, but one after the other. And that's very different from what I've coded in school and stuff. So I thought that was pretty interesting and something that I can like learn from and use in future coding practices. So, yeah.
For me, I think I learned the most from working on such a big project like an open source project. And I really learned how to like look through other people's code and also how important documenting code is and writing in like comments in the files, because that really helps me understand what was actually going on and how to write my own programs to work with it.
Yeah, I would definitely second documentation, especially since we are contributing to the open source project. It definitely is so much more of a priority to make sure that anybody who comes after you or wants to understand your code just is able to understand it and work off of it if they wanted to.
Okay, thanks for those answers. I guess another sort of related experience question. What was your favorite part of any of this, whether it be one of the tools or one of the experiences, anything that you would want to relay? I know we're going to learn about how the tools function, the tests function during the next talk next week, but if there's any foreshadowing you want to give about any of the really cool stuff that you've done.
So at least for me, I got to work a lot with Ansible, especially for provisioning the development environments. So that was a really cool experience because it's not something that you normally get to learn through coursework or even through most internships. So if there's anything I can say that I was really excited about working with or that I learned a lot from, it would be Ansible.
Okay, anybody else want to relay anything? All right, I'll throw one at Mark since he's been quiet and probably not paying very much attention here. Of the tools that you guys were sort of evaluating and developing this summer, did a lot of them check off boxes for longstanding things for the perfSONAR project? And if so, are these going to be featured in the future releases?
The answer is yes and yes. This effort this summer largely decimated the backlog of plugins that we had. So some of them had been around a while. We have a couple left that are a couple have sort of can of worms problems that we didn't want to throw at the interns because it would have been a little overwhelming. But I would anticipate that you will see the plugins that are going to be discussed next week, probably in the next feature release. So if you don't know, we just released 4.4 last week. The next feature release will probably be 5.0, which will probably happen later this year. We haven't nailed a date down for it, but being that the new plugins are new features, that's where they'll show up.
Okay. And while Mark is still on the hot seat here, has there been any wide-scale testing yet? And if there hasn't, is that something that you would want to start inquiring interested community members, perhaps some of those that may be on this call today, about trying to deploy and test?
Yeah, absolutely. And all of this stuff will of course end up in will end up in GitHub, and if people are interested in testing these things out, we have a nightly build that we do every night that has sort of like the bleeding edge stuff in it, so that will be able to be you can install that on a system if you want. But yeah, by all means, and I'll try not to spoil any of next week's talk, which is where we're going to talk about what the plugins are and what they do. But yeah, there will be lots of opportunity for that. We'll probably start running them in our own test bed, and some of the plugins require specialized environments, but we'll cover all that next week.
Okay, and Hans is requesting if you do have a GitHub link for those that may not be that integrated to the project, please drop it into the chat, and I'll make sure that I share that in the email as well.
Yep, Daniel's way ahead of us. Got it right in there.
There we go.
I can link the slides as well.
Oh yeah, absolutely. Yeah, please send me the slides. I'll make sure that those get posted for everybody who's here and for those that will be watching this on YouTube afterwards.
Yeah, the plugins that were listed in the slides are the current set that we ship. There's probably 6 or 7 that we've retired for various reasons, but what's in the slides is what ships right now.
Okay. Well, I'll put out one last call for questions here if anybody has any. Yep, and thank you, Daniel, for sharing the presentation link. I'll make sure that I capture a static copy of that. So one last call for questions, and I'll certainly thank all the speakers again. Very nice job, everybody, and glad everybody had a great experience this summer. Even though it's remote, it seems like a lot of good stuff was done for the community. And for everybody who's listening, and for everybody who will listen after the fact, we'll have the second part of this talk next week with, I think, probably the same set of speakers, maybe a couple more. And we will send out the abstract that talks a little bit about those tools, and hope everybody can join us next week. Thanks, everybody.
Jason, there was a question from Jim Warner that didn't get addressed in chat.
Oh, that may have went to you instead of me. I did not see it in chat.
Oh, okay.
If you want to read it out.
Oh, yeah. You know what? It absolutely did go directly to me. Yeah. So Jim asked. There's been a project going on for a summer or two at Michigan called pScheduler's, which is for Wi-Fi monitoring. I am not directly involved in that project. I will tell you that it is still underway. Excuse me. I believe Michigan is doing some beta testing of it on their own network, and part of the effort this summer was to take some of the code that had sort of been handwritten into programs that were part of the original version of pScheduler, and they've been broken out into pScheduler programs so that they'll be, or pScheduler plugins, so that they'll be able to you'll be able to run them individually using pScheduler. So yeah, that's not a dead effort, Jim.
All right, thanks for catching that, Mark. All right, hope everybody has a good weekend. Thanks again to the speakers, and we'll talk to everybody next week.
Thank you.